Good morning. Today, I'd like to begin talking about another method of doing certain integrals. These will involve trig substitutions. This is the reason that we just talked a little bit about trig functions and inverse trig functions. As an example of this sort of thing, let's look at the integral of x cubed over square root of 4 minus x squared dx. Before proceeding, I'd like to make a comment though. If this were just x to the first power upstairs, there would be no need to go through what we're about to. We could just do a u substitution. But in this case, we do have the x cubed. I have square root of 2 squared minus x squared. So I'll identify the a as being 2, and the u, in this case, will just be x. So making the indicated substitution, u will be 2 times sine theta, where theta is in the nice range, and since u and x are the same, my substitution is literally x equals 2 sine theta. As far as the quantity under the radical goes, if you want, you can write all of this out using the fact that x is 2 times sine theta. In the end, you'll get 2 absolute value cosine theta, but because of the range of theta values, that'll just be 2 times cosine theta. On the other hand, if x is 2 sine theta, the derivative of x with respect to theta is 2 cosine theta, so dx will be 2 cosine theta d theta. The only other piece in the integral that we haven't accounted for is the x cubed in the numerator. If x is 2 sine theta, x cubed will be 8 times the third power of sine theta. We can put all these little pieces together and we'll have done our first trig substitution. Putting all the pieces together, this is the integral that we have to do expressed in terms of theta, and we're immediately glad to see something. The 2 cosine thetas cancel each other out. The result, integral of 8 times sine cubed of theta d theta, is on the list of recipes that we know from the trig integral part. The power on the sine is an odd positive whole number. The suggestion was to split one such factor off and express the remainder in things that are related to the sine derivative-wise. Using our well-known trig identity, I can write sine squared of theta as 1 minus cosine squared of theta, and now things are actually very nice. I have a factor, sine of theta, which is very similar to the derivative of something else that's running around in the problem. It's very similar to the derivative of cosine theta. So what I'll do is a second layer of substitution. I'll let u equal cosine theta. Doing that substitution in the usual way and multiplying the 1 minus u squared with the negative 1, having made this substitution and doing the algebra with 1 minus u squared multiplied by negative 1, the remaining integral is 8 times the integral of u squared minus 1 du. This is easy. U squared minus 1 is a polynomial in terms of variable u. Integrating the polynomial, I get 8 times the quantity 1/3 u cubed minus u plus the constant of integration. Remembering that u is just cosine theta, I can write this back in terms of theta again. To finish expressing this back in terms of x, I need to remember what the relationship between x and theta was. X is 2 times sine theta, which I will manipulate into a form I can do some trigonometry with. A comment is in order, though. A lot of people will write this equation, sine theta equal x over 2, and say, well, I need cosine theta. So theta itself would be the arcsine of x divided by 2, and then for the cosine values, they will write down cosine of arcsine of x over 2. This is technically correct, but it's a little clunky looking. I'd rather have this back in more familiar functions of x. So I'm going to draw a right triangle. Drawing in a right triangle, which I have arranged so that sine of theta, which is opposite over hypotenuse, is equal to x divided by 2, if I knew the remaining side of that triangle, I could calculate any trig function of theta that I care to. X squared plus the unknown side squared must be 4. The Pythagorean theorem tells me that the unknown side squared must be 4 minus x squared, so the unknown side itself must be radical 4 minus x squared. Some people will expend a little bit more effort and from within the square brackets factor out a radical 4 minus x squared over 2 in an effort to make what remains look simpler. For our purposes, though, this will do. This is an integral of the thing that we started off with. As a second example, let's look at the integral of 2x minus 1 over radical 25 minus x squared with respect to x. Our radical a squared minus u squared idea is going to figure into this, but it's worth mentioning that I really should look at this and think for a moment before I start doing anything. To do this first integral, I'll make a u substitution. I'll let u equal 25 minus x squared. Integral number 1 is direct to evaluate, and in the second one, we have integral of 1 over radical a squared minus u squared, where a is equal to 5 and u is equal to x. The substitution u equal a sine theta will be x equal 5 times sine theta. Doing the suggested substitution, in the end, I have to calculate the integral of 1 with respect to variable theta, which is theta. Then I have to remember what the connection between theta and x is. Since x is 5 times sine theta is x divided by 5. Theta is the inverse sine of x divided by 5, so theta is the arcsine of x divided by 5. This is the value of integral number 2, which completes the calculation of our integral. If I have an integral that looks like this, the integral of x squared over square root of 16 minus the quantity squared of 2x plus 1, then it's a little bit different, but it's going to turn out not to be very difficult. The thing to focus on in this situation is what's underneath the square root sign. It's a squared minus u squared. If I think of the a as being 4 and the u as being 2x plus 1. The radical quantity and the differential are easy enough to convert over into the trig functions, but I do have one remaining issue. I have to write down x squared in terms of theta, so there is a little bit more work to do. X squared works out to be 4 times sine squared theta minus 2 sine theta plus 1/4. We now have all of the little bits and pieces involved in the integral expressed in terms of theta values. The cosine of theta in the denominator cancels with the cosine of theta beside the d theta. I'll have a factor of 2 above and a factor of 4 below. Altogether, that amounts to a factor of 1/2. In what remains, a constant is easy to integrate. Sine theta with respect to theta is easy to integrate, so the only remaining real issue is what to do about this 4 times sine squared of theta term. If you look on our big list of recipes, we have a suggestion. I'm supposed to use sine squared of theta is 1/2 times 1 minus cosine of 2 times theta. In 2 of the terms that remain, we're basically done, except in expressing sine of theta and cosine of theta in terms of x. There's still, at last, one last piece of work to do. I have to do something about this. If you'll consult on the big list of trig identities, sine of 2 theta is 2 times sine theta times cosine theta. Since 2x plus 1 is 4 times sine theta must be 2x plus 1 divided by 4. That tells me what I should write down for that factor. Also, I'm going to need to know what cosine of theta is, and I'm going to need to know what theta itself is, but none of these things should be difficult to get our hands on. Drawing the usual triangle, I can figure out that cosine of theta must equal this quantity, so we now know everything in our answer back in terms of x instead of theta. Again, people will often expend some effort trying to combine terms like these in some clever way in an effort to make it look nicer. For our purposes, though, I'm just going to call this done. I'm going to make several small videos like this, so for this one, the last example I want to look at is the integral of 1 over radical 7 minus x squared plus 6x. At first glance, that doesn't look like you can do anything with it, but if we use a common algebra technique, completing the square, we can actually do something with this. After completing the square, the thing that I'm integrating is 1 over square root of 16 minus the square of something. The something, the x minus 3, will be the u. U is going to be 4 times sine theta. We've done that kind of integral before, so all of the calculations involved are direct. In the end, the integral is theta plus a constant. Sine of theta is x minus 3 divided by 4, so theta is the arcsine of x minus 3 divided by 4. In an upcoming video, we'll look at some more variations on a theme of this idea. In the meantime, I hope everybody has a good day. I'll talk to you again soon.